Hello everybody, it's my pleasure to welcome you in my presentation titled Expanded Clay Applications in Internal Curing of Concrete. My name is Amin Akhnoukh. I'm an associate professor in the Construction Management Department at East Carolina University in Greenville, North Carolina, United States. First, let me briefly introduce what is the meaning of internal curing. As we all know, concrete past pouring needs to be cured in order to minimize the water loss due to evaporation, and that's a requirement to avoid excessive shrinkage, cracking at early age, and loss of compressive strengths. Currently, curing is mainly introduced to concrete by applying outside source or support with adding water to the outside surface of concrete, which is okay in compensating the water loss due to evaporation. However, for external curing, only the top strata of the concrete surface is nourished with water. The rest of the concrete or the concrete at the depth is not cured. So in internal curing, we use an agent to be embedded in concrete during mix design. Normally, this agent is a pre-wetted lightweight aggregate mixed with the concrete along the depths of the poured surface, so it provides water in a homogeneous manner so that every portion of the poured concrete section receives the same amount of curing. Internal curing was proven to produce 15% increase in hydration, which is a great advantage for concrete curing. It results definitely in a minimized cracking compared to external curing, in addition to the fact that lightweight aggregate used as an agent for concrete curing will definitely result in a reduced weight for the dead load of the structure. In my research, I've been using expanded clay as a lightweight aggregate as an agent in the internal curing of concrete. Expanded clay as compared to regular coarse aggregate produced by crushed limestone has a much higher absorption capacity for water. If you look at this table, we're talking about 15% compared to 0.4%. That is more than 30 times of the absorption capacity. So pre-wetting of expanded clay would absorb a lot of water that can be introduced to the poured section as an internal curing technique. In addition, the expanded clay weighs less than half. If you look at the specific gravity, that results in a lot of saving in the structure dead load or the structure weight. In my research, I produced multiple mixes. A first mix is a control mix, and that is to target a regular strength of 7,000 to 9,000 pounds per square inch for a 4x8 cylinder. Water cement ratio is kept at a 0.45, the weight of water to the weight of cement. And then the clay 100, clay 200, clay 300 are three developed mixes using the lightweight expanded clay in partial replacement of coarse aggregate. So here clay 100, instead of using 1700 of coarse aggregate, we're using 1600 pounds only in addition to 100 pound of lightweight. Here it's 1500 and 200 of lightweight for clay 200 and 300 lightweight expanded clay plus 1400 pounds of coarse aggregate for the mixed clay 300. Produced cylinders and specimens were kept at the same condition for curing, and then we started running the testing for them. For compressive strengths, we used ASTM C39 by crushing 4x8 cylinders at average ages of day, 3 days, 7 days, 14, and 28. Looking at the results for day 1, 7, and 28, we can see that the clay 100, 200, and 300 results on close strengths as compared to the regular coarse aggregates. Now, running the shrinkage test using ASTM C157, molds of 20-inch length and 1 inch by 1 inch cross section was poured using the control mix, the clay 100, clay 200, and clay 300, and their expansion was measured with age from day 1 to day 5 here, and you can see that using internal curing agents results in a shrinkage, a lot of shrinkage. Here, let's say using 20 and 30 clay, we're talking about 240 microstrain as compared to close to 300. We are talking about 20-25%, sometimes close to 30% saving in microstrain in shrinkage of concrete. That is a great step in stopping shrinkage at early age for freshly poured concrete using lightweight aggregates as internal curing agents. So, in conclusion, expanded clays can be successfully used in producing internally cured concrete. The expanded clays result in shrinkage reduction of up to 30%. That is a requirement for surfaces exposed to aggressive environmental attacks like bridge decks per se. Lightweight aggregates also reduce in structural weight. If you look at the mixes, losing 300 pounds of the concrete weight per cubic yard, that is close to 8% of the dead load of the structure. That's a significant reduction in dead loads. Finally, the negative impact of lightweight aggregates on the compressive strength of the concrete is minimal. I'd like to thank you for listening and attending my presentation. Should you have any questions, please feel free to email me at my email akhnoukh17@ecu.edu. I'll be more than happy to respond back to your questions. Thank you.